This is a Heath HM-2102 VHF Wattmeter. This one caught my eye at a hamfest. I was going down the row and I saw this thing, and what caught my eye was this, a switch on the front. And it's got the letter F and R, which I'm assuming means forward and reverse. So someone modified one of these. And I always like these meters. They're pretty nice. In fact, I've got another one here, same meter, only it's not modified, of course. So what I want to do, first of all, I want to figure out what they did. I have a feeling that I know what they did, but I want to take it apart and find out what this modification was. And then I want to test it and make sure it's calibrated so I can use it with my equipment. So what I'm going to do, I'll take it apart and we'll go over and find out what was done here and then move forward. So stand by. One quick observation here. It's got a few screws missing. Here's a screw that doesn't match the other screws. Another screw missing, doesn't match. That's always a bad sign when you get stuff from Hamfest. Something to look for is, look at the screws. Do they look like they're have been used quite a few times and maybe they're slightly damaged? That'll let you know someone's been in it. Of course, most of this old ham stuff, there's been a lot of hands in them, so that may be an indicator of what we're about to find, but we'll see. Whoever owned this meter did a modification to it, and I like the modification that they did. One thing I never liked about these meters, either the 2102 or the 102, was when you set to measure SWR, when you set the meter at full scale, you'd put the mode switch in SWR, turn up, pull out this, it's got a switch in here you can see. You'd pull out the switch and then you would turn it up to full scale, and then to read SWR you'd push it in. And what would a lot of times happen when you push it in, this would be moved just a teeny bit, which would affect your reading. So what this person did, they replaced this slide switch that runs on the same control as the pot here. They replaced this single pole double pole slide switch with a single pole double pole toggle switch. Obviously it'll need recalibrating, but I like what they did, because that way you can set the meter to full scale and then flip the switch. You don't have to worry about moving this when you change it. So in other words, turn it on SWR, set it at full scale, and then instead of pushing the switch in, you just throw the switch. So really, you could take, if you wanted to, you could just pull this pot out and replace it. What they did, they just cut the leads off here. The red lead they connected to the switch here, and the black lead, which went to the center pin, they just moved over on here. Here you can see what they did. Here's on the schematic here. Here's this switch here is this switch here, and they just replaced this with this switch. So the red lead here, which was on here, was moved to here, and the black lead from C to this switch was connected to the other side, and then the center position here just goes over to the pot, which would have been 5 on this switch, goes to the wiper of the pot, you can see there. So I kind of like what they did there. This ceramic disc capacitor here is C16. This side's grounded, and this side is connected over here to the anode of D3 and one side of this resistor, this 51 ohm resistor, and that leg is running awfully close to this trace here, so I'm gonna move that out just a little bit. I don't like how close that is to that. I'm gonna leave the switch on here in case someday somebody wants to reconvert this back to stock. I don't know why. I'm gonna play around with this when I get done here cleaning up this switch here, but I do like the idea what they did here. So I'm gonna clean up the switch and then we'll put it back together, and of course it's gonna have to be calibrated. A little deoxit in the cup, and you can see how filthy that contact is on that switch. That's many years of who knows what. Yeah, I think I'll go through a few Q-tips before I get this clean. Well, it's starting to look better. Anyway, you get the idea. Well, the switch contact's cleaned up pretty good. I'm going to give the pot a shot of this stuff. Fader F5 deoxit fader lube. This stuff's really good. Just need a little shot in there. And of course rotate it. I think that'll work. If you do some of this preventative maintenance, a lot of the problems you'll find will disappear before you even try here. Of course, I don't know what condition the component's in. I'm going to test it before I go too far as far as trying to troubleshoot anything. They did a nice job of wiring this, actually. The soldering all looks pretty good. I have my trusty HTX-202 running off of a 12 volt supply, and I've got the output running through the Heath kit HM-2102, should point over to here, and the output of that goes through the Bird 43, and the output of the Bird 43 goes into a Bird dummy load over here on the right. I'm going to key the transmitter, and over here on the right I'm going to adjust the calibration pot so the Heath corresponds to the Bird. So here's transmit 5 watts, and we'll adjust a little too much there. Oops. Never say oops. That's pretty darn close, maybe. I'm going to put the meter in SWR. You always want to crank this maximum counterclockwise so you don't peg the needle. Now, it's in SWR, and I'm going to turn up the pot for full scale deflection. Right about there, allowing for parallax. Now I'm going to flip the switch. Now see, I like that a lot better than doing this, because every time you do this, you move it just a teeny bit. So I like the modification the guy did there. I think I'll modify my other one, do the same thing. While I have this apart, I'm going to do a modification to the sensing board here. This modification is on the internet if you're interested, but anyway, what it entails is replacing R8, this resistor right here. If you look on the schematic, R8 is a 68K resistor. It's a carbon resistor here. It is a 5%, but they tend to increase value with age, and the way this works here in the calibration procedure, you basically calibrate this. The R7 here is used, if you look at the switching arrangement here, in the 0 to 25 watt range, and in the 0 to 250 watt range they connect in R8 in series with R7. So if you calibrate this in the 25 watt range using R6, this pot here, this is the calibration pot right here. You calibrate it in the 25 watt range, but there's no way to adjust the 250 watt range because this is a fixed resistor. So what I'm going to do, I'm going to replace R8 with a pot, with a trim pot. And I've got a little Allen Bradley trim pot here, so I'll use that. I don't know what the power rating I need here because I don't know what the full scale current rating of the meter is. So just for experimental purposes, I'm going to assume, let's say this was a 1 milliamp meter movement here. And with a 68K resistor, that would be, since P equals I squared R, that would give you a power dissipation of about 68 milliwatts. So I think this pot isn't going to be too critical. Anyway, we'll find out once I put it in. But anyway, that'll give me the opportunity to calibrate this on both the 25 watt and the 250 watt range. So I'm going to do that and then recalibrate it and then go from there. And if you're interested, I'll this is a schematic of the watt meter here. I'll do a brief description of the schematic if you're interested after this. So stand by. I have an ICOM IC2000 transmitter here. Got on higher power here. I already calibrated the 25 watt range here using the bird. I only have a 25 watt slug for 100 to 250 megahertz, so I'm going to use the leader over here. I've got the leader on the 120 watt scale. This has a built-in dummy load, by the way. So I'll key the transmitter. We're getting just under 55 watts. And the HM-2102 is showing it's measuring low. So now using this pot I just installed, I'll adjust this to 55 watts. Right there. Now the 250 watt scale is accurate on the Heath here. At least compared to the leader here. And I've noticed this one, I've compared this one to the bird, and it seems to be quite accurate. I'm going to briefly go over the circuitry of the HM-2102 here, and that'll be next. Here's a brief description of the circuitry used in the Heath HM-2102. There's a schematic diagram here. This is the sensor part of the unit here, and this is a circuit board. Each of these little connections here are where the wiring harness comes in here. There's a ferrite bead on each of these leads. So it's basically all the RF is contained in this box, and coming out through the multi-conductor cable is DC to the front panel. So you can mount this unit away from the operating desk, there's a length of cable here. I don't know how long it is, probably about 4 or 5 feet. So you don't have to run your coax right up to the meter here, which is kind of nice. If you look at here, here's the input and output, which are UHF connectors on the back. I think I'm going to change these to N though, eventually. If you look here, this is basically a line section that runs right through the unit. And if you look here, you'll see a small toroid transformer, and there's a line section which is basically just a wire that runs between the two center conductors of the connectors, the UHF connectors. And what they do, there's a toroid, and that line section runs through the toroid. It will induce a voltage in the winding of this toroid. So looking at it, looks like a current transformer to me, basically at RF. So anyway, both ends of this coil, this is basically a transformer with a one-turn primary, and here's the secondary. Anyway, these two sides of the coil are opposite polarity. So in measuring power here, the RF induces a voltage in this winding, and this side, the voltage is rectified by D3, and there's a cap here, C7, that smooths out that rectified voltage. And it's fed down here through the calibration pot. It has two power ranges, 25 watts and 250 watts. In the 25 watt range, R7 is a multiplier for the meter, and if you look here, when the switch is in this position here, the connection goes directly to the meter. In the 250 watt range, the multiplier consists of R7 and R8 here, so they're both in series, and they come in through this line here on G. And of course, here's the meter. You got the positive and then the ground here. Now for the reflected power, on the right side of the toroid here, you'll see it's connected to D2. This rectifies the reflected energy coming back through the toroid here. And that's rectified, converted to a voltage, and that's fed into the sensitivity switch here. This unit was modified before I got it, where they replaced this switch with a external single pole double throw switch, which I like. I'm going to do that to my other unit. And then it goes through the sensitivity control here. This is in the front. When you adjust it for measuring SWR here, you use the sensitivity control. This circuitry here, there's a tap C1, and then you've got a rectifier D1 here. This is used to calibrate the unit, but I didn't use any of this circuitry here because I calibrated mine using external wattmeters as a standard and a dummy load, so you can omit this if you want to calibrate it to another meter. But when this was made back in the day in the 1970s, a lot of hams didn't have accurate meters, so they had a way of calibrating it. See, it says jumper here. You connect this lead from norm to calibrate, and then you would calibrate the meter, and then to operate it you'd put this jumper back in the normal position. That's the jumper right there, normal and calibrate. Not used in my situation here. This circuit here is to balance the SWR circuit here. You've got a trim capacitor C4 here, and that's this cap here. And that basically, when you calibrate the unit here, when you set it up, you basically null out the lowest level here with this trim cap in the SWR mode here. There again, here's the calibration pot, R6 here, and then I removed R8 and replaced it here with a 100K pot. I got this idea on the internet. Good idea. They use this so you can get a more accurate calibration of the higher wattage range here. So this is basically a reflectometer type measurement. These have been around for a long time. I've seen where they actually use a piece of like RG8 coax instead of just a wire here like they did here, and then they would slice the coax and couple it into the circuitry. So there's different ways of doing this. One of the limitations of this as far as frequency is in here. This the size of this toroid and the internal wiring here, if you get up too high in frequency, circuitry isn't going to work. That's why this is limited to VHF, a 2 meter band, ham band. It can operate on 6 meters also. Anyway, that's a quick rundown of the circuit. I remember these units, they were out when I was a young ham back in the early 70s, so it's been around a long time. You see these at Hamfest. If you do get one of these, you might want to consider this option for calibrating here. Replace R8 with a trimmer potentiometer so you can adjust it right on, especially if you have an accurate meter. Here's a quick tip for you here. When you want to power these units, a lot of guys will get these Anderson power poles, and they're really nice, but there's another option. And that's these XT60 and XT90 connectors here. I really like these. But anyway, you have a male and a female connector here. And they're quite sturdy here. They make contact. This particular one has a little piece on the end here that can cover the wires here. Or you can use shrink wrap also. But anyway, I use these to power up all my 12 volt equipment. And I really like them here. They're very inexpensive too. And they're of course polarized so you don't blow the thing up. Anyway, that's just a quick tip. Here it is back together. Yeah, it's measuring just a hair high, but close enough for what I'm doing with it. If I need accuracy, I use the bird. Anyway, and just in passing here, I found this article in the February 1976 issue of Ham Radio magazine, which is, in my mind, the best amateur radio magazine ever made. 73 was pretty good too. But anyway, this article in that issue was high power calibration for the Heath HM-2102 Wattmeter. They got a different modification you can do in here. Anyway, if you're interested, it's the February 1976 issue of Ham Radio magazine, and that's available on the internet. Anyway, short video. I hope you enjoyed it. I like these meters. So anyway, I don't have a lot of Heath equipment, although I do have an old Heath Marauder I'm thinking of working on here. It's an old vacuum tube rig, but if I ever get that working, I've got the HF version of this that I'll use to work on that. Anyway, that's it for this one. Thank you for watching, and we'll see you in the next one. Bye for now.